Okay, hello everyone. Today we have this example from chapter 4, velocity field, streamlines, path lines, and acceleration. So we're given this velocity vector of a 2D flow, x times 1 plus 2t I hat plus y j hat. And we want to find equations for the streamlines, path lines passing through the point 1, 1 at time 0. And in part B, we want to find the acceleration. Okay, and we know that this first term, because of the I hat, that's the horizontal velocity u, and the second term, because of the j hat, that has to be the vertical velocity v. So we're going to start with that. We will start with the streamline. And we know that the streamline can be found by integrating this equation. This comes from the fact that on a streamline at any point, the slope is the same as the velocity, the direction of the velocity, right? So dy dx is v over u. And in this case, v is y, u is x times 1 plus 2t, okay? So we have to integrate this, and this is a separable equation, right? So I can write it like this. I can say 1 plus 2t dy over y. So I'm taking the y terms to the left-hand side is dx over x. And the x terms to the right-hand side. And now we want to integrate that. Remember, when you're integrating with respect to x or y, you can treat this time as a constant, right? You don't need to integrate that, which means the integration will be 1 plus 2t. Again, I can pull that out of the integral. dy over y is the integral of dx over x. Okay. Again, 1 plus 2t, we're not going to integrate that. dy over y is ln y, and dx over x, the integral of that is ln x, plus some c, which comes from the fact that we have an indefinite integral. And how do we find c? Well, we find c by using the initial condition that's given to us, okay? Okay. And of course, we can simplify this a little bit. If you want, you can write it like this. You can say ln y1 plus 2t is ln x plus c. Or you can just keep it in this form. It doesn't really matter. So let's just go to the previous form. And again, how do we find this constant c? That comes from applying our initial condition, which says at t equals to 0, x is 1, y is 1. So if we apply that, what do we get? We get 1 plus 2 times 0 is ln1, sorry, times ln1 is equal to ln1 plus c. Right? Okay. Now, this left-hand side, this is just ln1, right? This is also ln1. So that means c can only be 0, right? So c has to be 0. And that just means that at time 0, the equation for the streamline is 1 plus 0, ln y is ln x, which is just another way of saying x is equal to y or y is equal to x. Okay. So again, what are the steps? We start with the streamline equation, dy over dx is v over u. We plug in the v and u for this velocity field, then we integrate similar to the example from the textbook. Once you integrate, you apply the initial condition, which says at time 0, x and y have to be 1. So you plug that in, you find that the constant c is 0. And so at time 0, the streamline equation is x equals to y, right? And geometrically, if you can visualize this, this is just the line like this. So if this is the origin here, then the streamline is just this line of x equals to y. Okay. All right, so that is part 1 of part A, finding the streamline. Okay, so now let's continue with the path line. Let's try to find the path line. First, let's remind ourselves what a path line is. It's basically the trajectory of fluid particle, right? Of a fluid particle. So basically, if you follow a particle and just trace out its trajectory, that will be the path line. Of course, that means that the path line is governed by u being equal to dx dt, right? So that's just the definition of u, and v is dy dt. That's the definition of u and v, right? So in this example, again, remember what is u? U is x times 1 plus 2t. And what is v? V is just y. Okay, and what we will try to do is just get a formula for x and y versus time. We want to find x and y as a function of time. So all we have to do is just integrate these. These are very easy differential equations because they're separable. So all we have to do in this case, for example, is just take the x terms to one side and the t terms to the other side. And then you just integrate that, right? We can do the same thing in the y direction. So we get dy over y is dt. And then we just need to integrate, right? So the first one is ln x equals the integral of 1 is t, or 1 dt is t, plus the integral of 2t dt is t squared, plus some constant, I'm going to call that c1. This integral is just ln y is t plus c2, right? So again, very straightforward integrals, very easy differential equations. And so what do we get? Let me write this down here again. We found that we know ln x is t plus t squared plus c, and ln y is t plus c2. Okay, now how do we find c1 and c2? Initial conditions, of course. Again, remember that at t0, right, x has to be equal to 1 and y has to be, y has to be equal to 1 as well, right? So let's write that down, that x is equal to 1 at t0 and y is equal to 1 at t0. So if I plug that in, I will get ln 1 is 0 plus 0 plus c1, and ln 1 is 0 plus c2. Okay. Okay, now what is ln1? ln1 is 0, right? So what we find is C1 and C2 are both equal to 0. Okay, so that makes it very easy for us. If I go back to these two equations that we found, and I plug in those C1 and C2, we get ln x is t plus t squared, and ln y is t. And of course, it's easier if we just get explicitly x and y in terms of t. So all I have to do is just take the exponential. So exponential of ln x is just x. Exponential of the right-hand side, we're going to write it as exp of t plus t squared. And we do the same thing here. We get y is e to the t. Okay, and that is where these are together, the pathline equations. So this gives me the trajectory of a fluid particle that passes through that point at time 0 as a function of time. So this is the pathline equation, and this one was the streamline. Okay. And as we can see, the equations are different because you have an unsteady flow, right? Depends on time. We said that these equations, pathline, streamline will be the same if you have a steady flow, right? So I'm going to say here, pathline not the same as streamline because it's unsteady flow. All right, so hopefully that is clear. Now we are done with part A. Let's go back to the problem statement. Part B just wants us to find the the acceleration vector. So V is given to us. We just want to find A, right? So this is easier than part A because all we have to do is use the substantial or material derivative formula. So U is x times 1 plus 2t, V is y, and we want to find A, right? A is ax I hat plus ay j hat. And remember that ax is du dt plus u du dx plus v du dy plus w du dz. Okay, so let's start with this. What's du dt? Du dt here is going to be 2x, right? Right, because u is x plus 2xt. And if you take the derivative of that with respect to time, this is 0. So this one is 2x, so that will be du dt. Okay, plus u, which is again x times 1 plus 2t times du dx, right? And du dx is 1 plus 2t. Okay, let me move this a little bit to the left. Make sure I'm recording. Okay, so that is u du dx. Actually, let me write this all down here. Like a mapping to each term. Okay. Okay, what about v du dy? So v is y, right? But du dy is 0, right? because there is no y in u, so that's 0. And for the same reason, du dz is 0, and also w is 0. There's no w, which means this other two terms are 0. So ax is just 2x plus x 1 plus 2t squared. Okay, so that's ax. What about ay? Ay is dv dt plus u dv dx plus v dv dy plus w dv dz. So dv dt is 0 because v doesn't depend on time, so that's 0. Plus u dv dx, v doesn't change in time either, so that is 0 as well, right? So this is 0, this is 0. V dv dy, now this is not 0 because v is y and dv dy is just 1, so that's y, plus 0 because there's no w or dv dz, so ay will be just equal to y. And to summarize, we got this acceleration vector a, which is 2x plus x times 1 plus t squared I hat plus y j hat. Okay, and that's our final answer. Okay, so that's our example from chapter 4, our extra example. I think the acceleration part is not very difficult, but you need to pay attention to the streamline and pathline. It's just also not difficult, but especially the pathline part is a little bit new. So make sure to study this, try to do it on your own, and let me know if you have any questions, okay? Great, thank you.